Basic differentiation, the 10th and final video for this topic. Consider the curve f of x equals x cubed plus 2x minus 7 by way of an example. And let's say the curve looks something like this, and we wanted to look over this interval at what the values were. Let's say between x was 2 and maybe something like x was 10 for that one there, or whatever the question happened to ask. And I asked you what's to work out the minimum and maximum values of the curve between 2 and 10. You'd rightly say, well, that's quite easy to work out. When x is 2 will give me the minimum, so I'll substitute 2 into here. F of 2 is 2 cubed plus 2 2's take away 7. Get that value, that will be the minimum. Do the same thing here for the maximum value. So these are called endpoints. So when the endpoint when x is 10, I'll substitute 10 in here, 10 cubed and so on. And that will give me my minimum and maximum values by substituting the endpoints of the interval into the formula. That gives me my minimum and maximum. But what if the graph was not this shape? Let's say it perhaps came something more like this. And if that was the shape of my graph, and I said, what's the maximum minimum values there? Yes, we have to look at the endpoints, but we also, for the maximum, we say the maximum is not over here, the maximum is now up here, because there's a stationary point there, a maximum turning point, which is higher than the endpoint. So I'd need to work out this stationary point and find out what the y-coordinate is there. That would be the maximum. There's a minimum turning point here, but that's okay, it's above this endpoint. But of course, if the graph is a different shape, or this came lower down and then turned up, or it crossed here at a higher value, then this stationary point might also be the minimum value and not an endpoint. So we have to look at the endpoints and get values there, but also consider the stationary points inside the interval between the limits of the interval there, and check out the values there and see if one of them may be the maximum or minimum. On page 12 of your notes, let's have a look at the example there, please. All right, you'll notice that I've changed the question, so please change the one in your notes. A slightly better example, f of x, 2x cubed, take away 6x squared, take away 18x, add 5. We want to find the maximum minimum values when x is between -2 and 1, or equal to either of those, less than or equal to -2 and less than or equal to 1. So, we know we're going to have to substitute the endpoints into my formula here, but also find any stationary points. So let's work out stationary points. We know how to do that and score marks immediately for saying f dash x, knowing to differentiate, will be 6x squared, take away 12x, take away 18. And there's my derivative. Scoring marks again in the exam. Now let's set the derivative equal to 0. So 6x squared minus 12x take away 18 equals 0, because that tells me stationary points. And remember, for writing equals 0, scores marks. I want to solve this. It's a quadratic or a trinomial, so I'm going to factorize. Take a common factor first. Everything divides by 6. Now I'm going to factorize this term in here. That'll give me 2 brackets. Still always writing equals 0. X and x. 3 times 1 and a negative on that one. I know 6 is not equal to 0, so I'll say one of these 2 brackets must be 0. So x take away 3 is 0. It says x must be 3 is a stationary point. Or x plus 1 equals 0. So x could be -1. Would also give me a stationary point. So I'm going to substitute these in, except when I look at these values, x is 3 and x is -1, 3 does not lie between -2 and +1. 3 is outside of that interval, so I don't need to worry about the x equals 3. That's not part of the question anymore. But the negative 1, well, of course, that does lie between negative 2 and plus 1, so I need to consider my endpoints and the negative 1. I'm going to substitute them back into the first equation. First equation tells me y-coordinates, which is the same as values. Second equation, of course, is always gradients or rate of change. So, doesn't matter the order. I'm already working with the stationary point here, so I'm just going to keep going. So I'm going to go with x is negative 1. So I'm going to say for x is negative 1, original equation, f of negative 1, 2 lots of negative 1 cubed minus 6 lots of negative 1 squared. Take away 18 times negative 1 plus 5. And if I process all that, then I'll say I've got it's minus 2, take away 6 plus 18 plus 5 would be 15. I don't need to write it down, but just for my own idea of to see what's going on, I'm going to write the coordinates of the point then. That's a stationary point at negative 1, 15. But say the main point is that the value of this stationary point when x is negative 1 gives us a y-coordinate of 15. That, as we said, is the only stationary point I need to worry about since this is outside the interval, but I better look at the endpoints. So let's take x as negative 2. So for x equals negative 2, that's f of negative 2, 2 lots of negative 2 cubed, take away 6 lots of negative 2, take away negative 2 squared, 18 times negative 2, plus 5, which gives me minus 16, take away 24, plus 36, plus 5. So f of negative 2 works out to be 1. And again, don't need to, but if I wrote down that, that's an endpoint of negative 2, 1. So far, my maximum value is 15, minimum value is 1. But things can change again, because I have the other endpoint to consider, x less than or equal to 1. So, once again, for x equals 1, put the value of 1 into my original equation. 2 lots of 1 cubed, take away 6 lots of 1 squared, minus 18 lots of 1, plus 5, that's 2, take away 6, take away 18, plus 5, equals negative 17.117. Now for this, for knowing to substitute and carrying out the process of putting my stationary points, or the relevant stationary points, and my 2 endpoints in, that scores another couple of marks right there. We're not quite done though. Having established the values, we have to then write down the conclusion as to what the maximum and minimum is, because that's what the question said, and so far we've not clearly stated that. So I'm just going to say the maximum value equals, compare my answers here, 15, 1, and negative 17. So I'm going to say maximum value equals 15. Right? I'm not asked to do it in this particular question. Sometimes you are, so watch. So it happened when x was negative 1. It gave me my 15. Right? As I say, I'm not asked to, but I've done the work, so I may as well note it down. And as I say, sometimes you're asked to do that. So watch for that. Don't throw away marks when you've done all the working. You just don't write the thing down. Minimum value is from my three values, negative 17. That occurred when x equals 1. And for just stating what seems perhaps quite obvious from my results, which is the maximum value and which is the minimum, that gives me a mark. Can I also point out that every textbook I've seen on doing this, when they're working out the stationary point, right, and let's say we're wanting to establish if it's a maximum or minimum, people often then go ahead and they do a nature table to find out the nature of the stationary point here. It's not necessary to answer the question, because just by comparing these answers here, here, and here. Now, in fact, this one must be a maximum turning point here because it gave me a maximum value and it wasn't on the end, right? At other times, it might be a point of inflection or something like that, but it's not necessary to score the marks to do the nature table. So even though textbooks do that, it's not required so long as you work out the y values. Having said that, if you've got plenty of time, it doesn't hurt to do that just as a check. And if it was a nature table said this was a maximum turning point and it was the only stationary point in the interval, then it would follow that this must be the maximum value overall. But it's only as a check to say we don't need to do it, especially for short of time in the exam. So make sure, please, that you substitute the endpoints of the interval and that you find any stationary points that are within the interval, right? Could be both, could be one, could be neither. Work out the y coordinate, which gives us the value, and then make a statement, and that's it done. A fairly straightforward 7 or 8 marks.